This is the episode 49 of the Peer-to-Peer Network coding session series. And today I would like to make an explanation only, not coding or debugging. The first part is going to be for users or people willing to test this. And the second part, I'm going to get to explain more or less how the code is organized as we ended the version number 2 of the peer-to-peer network, the second iteration, let's say. Okay, so let's jump into that first part of the explanation for users. Okay, so you should locate this workspace that is called a network, peer-to-peer network demo. Here you will find these components. These are peer-to-peer network nodes, and they define the public networks that are going to be available for anybody to add nodes to it. Okay, so today we are defining mainnet and testnet only, but in the future we may add, for whatever reason, we might add more networks, more public networks if needed. Okay. So the rest of the configuration, as you can see here, there are no children for these guys. Okay, only the code name, mainnet or testnet. The rest of the configuration is up to every user. Okay, so a peer-to-peer network, a SuperAlgo's peer-to-peer network, is a concept, but physically it manifests itself as a network of nodes, of network nodes. Okay. So who runs these network nodes? Well, any SuperAlgos user. So that means that at your user profile, you can configure which are the nodes that you're going to be running. And of course, you will be able to define to which network you want these nodes to belong to. Okay. So let's check my user profile as an example. You will see here that we have I have two network nodes defined. One is number 1 and number 2. And both cases, I am connecting these nodes to the peer-to-peer network that we call testnet. It's a public network. Okay. Here you have this one connected there, and this one is connected to another type of network because we have the concept of public and permission, or public and closed, or private, or permissionless and permission. Okay, as you want, are synonyms. So any user can also define a private network, a permission network. Okay, and you do it like this. You add this node, and then you put a node here, and you set a name for your permission network. Okay, in this case it's going to be called like this. Okay, and in the case for permission networks, you are able to grant permission to certain users. Okay, so if you reference here somebody, for instance, I can reference myself and I will have permission for this network. Okay, so in the same way, you can add all the users that you want to your private networks of nodes. Okay, so when anybody uh, defines a node and defines that is belonging to a certain private network or public network, that means that at runtime the node is going to connect to peers only that are defining themselves to belong to this network, which is exactly the purpose for this. Okay, so to recap, any user can create a private network or permission network, and uh, any user can provide nodes to that permission network, okay? And as long as the profile has permission to that network, those nodes are going to be accepted to belong to that network. And uh, also users that have permissions granted, okay, to access those nodes are going to be able to connect to those nodes and to see what is going on at that network, okay? So this is one aspect. And what else do we have here? At your peer-to-peer network nodes definitions, okay? These are definitions. You also need to specify which network service you wish your network node to be running, okay? At version 2 of the peer-to-peer network project or the network project, we have two different network services available, okay? One is the social graph network service. The other one is a trading signals network service. What this means is that without these network services, the node is still going to be running as a network node. It's going to connect to the peers, but it will be kind of useless because clients will not be able to query or to do anything with them because they are just a shell, okay? In order for them to have any usage at all, they need to run at least one network service. And the two possible availables are a social graph, that is like the backbone for the social applications, or the trading signal, that is the backbone for trading signal distribution over peer-to-peer networks, okay? So this is my setup, and as you can see, I have one node connected to testnet, another node connected to this bata private network that I define myself, okay? So in both cases, I am running the two possible network service that we will have. So this is version 2 of the peer-to-peer network. What is coming next is the following. This is just an update of what is going on and being built. You will have another node that is going to be called network interfaces, where you will have some children here and the different interfaces that the network, your network node is going to be running at runtime, okay? So today the network node has the possibility to run two interfaces. One is a WebSocket interface and the other is an HTTP interface. These are communication layer, low level interfaces, okay? And these are the gateways that provide access to the nodes that are running to, and through them to the functionality that the node is providing, okay? Um, we are also developing, or somebody is also developing, a WebRTC interface in order to allow nodes to run inside your own home, overcoming the problem with firewalls and the impossibility to receive incoming connections. So that is a work in progress. So you will also see, once this is done, the WebRTC interface, so that you can decide which interfaces your node is going to be running. Okay, cool. So this is what you need to know. And as a user, the way to run this is you come to your console. Okay, for example, here I will run the network node, and it's very easy. I just go here. Okay, and just type node network. Okay, node network, and there it is. So as you can see, I run in the social graph network service running, the trading signals network service running. The network node WebSocket interface that is not at the UI, but is as of today in this current version, both interfaces are going to be running. So this is listening at this port, the HTTP interface listening at this port, and this comes from here because when you configure your network node, you define the host, the WebSocket interface, and the HTTP interface that is called web port. Somebody has to refactor this someday. Okay, so these are the same ports that are running there. Okay, so the network code name is testnet because our node is pointing to the testnet network. So this is a node now belonging to testnet. Okay, and network app. Okay, and the overall network app, that is the application that is running the node, is running. Okay, this is a message belonging to the social graph service. Okay, probably I should put these messages with a prefix of the service that is logging this stuff. Okay, that's a good idea. Okay, so one question you may ask is how does my system knows that I want to run network node number one, that by the way is not saying which one is running. Probably I should add these two, because if you see my profile, I have two network nodes, not one. Okay, so why is it running number one, that is the one connected to testnet, and not number two? Okay, the answer is because sorry, I'm going to use this workspace here to show you. First, let me close this and this. We have an environment file with all the environment definition, and there is some one of the variables that is called network. Okay, network node. Well, the variable name is called network node sign-in account. Not sure this is the more intuitive name, but essentially it has the code name. Probably it should be called network node code name. Okay, because this is the code name of the network node that I want to run in my current installation. Okay, so for each instance of for each installation of SuperAlgos, that means that you will be able to run one node. Okay, which is kind of logical, but just clarifying that. So this here is what you see here, and that is the reason why it's running number one and not number two. Okay, there are a few other parameters that you can configure if you if we make a if we might highlight it in this way. Okay, and these are the parameters. Max incoming clients, it means how many clients, that mean applications, can connect to this node. In this case, two. That means that more than two is going to start rejecting connections. Okay, this is something for you to decide how many your node will accept. Then how many incoming peers connection you want to accept. In this case, we put 0 because I am always testing this in a standalone way. But normally, you should put some positive number here, like for example 10. That would mean that 10 other nodes will be able to connect to your node. Okay, and how many outgoing connections this node is going to have. So this node will try to connect as many nodes as it can below the number that you configure here. So if you put 10, then it means that if it cans, it will connect to 10 other network nodes on the same network, okay? And being connected to other nodes is useful for distributing the information that needs to be distributed. For example, in the case of social trading service or network service, the events that happens at the application, for example, when you follow somebody, needs to be distributed among other peers. So, and that goes through these outgoing peers connections into the incoming peer connection of the other nodes. Okay, and then they pass the information all over until all the nodes have them. Okay. Also, the trading signals, that is another network service that is already developed there, are sending the information through these outgoing connections. Okay. Okay, so this is what you need to know as a user. The final thing that I would say as a user is this concept of signing accounts. A signing account is storing the signature of the profile handle or the username at the storage provider, that in this case is GitHub, okay, storage provider. And the idea is that each entity that interacts with the network, including the network node themselves, they should have an identity that they can prove cryptographically, okay? So they need for their identity a private key, and so that's why there is this signing account, okay, is represent a public key or a blockchain account that belongs to a private key that this network node knows, okay. So this is generated with the profile constructor that you already know when you run this procedure install signing accounts. This procedure scans all the entities that you have in your profile that needs a signing account, and it generates a random a private key, and then it signs the message that needs to be stored here in order for later to at runtime authenticating the nodes against each other or the clients that are connecting to this node, and making sure that you are getting somebody to connect to your node that they have a proper user profile with all the definition right and they are not impersonating anybody else. Okay, so all of this is what you need to know to run your own node. um, at this point in time, some users are starting to run their first nodes ever public at the public internet. Okay, so for the first time there will be some nodes. I know about two as of today, and that means that this is the birth of the superalgos constellation of peer-to-peer networks, because there's no only one. There are publics and privates. So this is the start of all this stuff. If you want to run your own node, you just need to make this configuration in the whatever way you want. Don't forget to sign to create the signing account. Once you finish uh, all all your configurations here, you have to take into account that every time you run the procedure, all these private keys are recalculated. So that means that um, there is no big problem with that. But if you are running different machines with different nodes, okay, every time you add a new node today and you create a signing account for them, then you will need to copy a file with that includes the private keys. Okay, there is today we have this file that is on a git ignore folder called my secrets, that has the signing account secret. That means the private key of this node with these identities. Okay. Um, So this file is generated as an output of the process of install signing account. So if you run the process again, make sure to copy this file to all the computers where you have your different installations that need to access the peer-to-peer network. If they don't need to access the peer-to-peer network, they don't worry because it's not useful for any other thing. Okay. Also, at this current version, that is just version number 2, we are not encrypting yet this file. This is something that is coming in future versions, so keep that in mind. This file or any of the other file, none of this file includes the private key of your profile where you're holding your SA tokens. Okay, so don't worry about that. The private key with the tokens are not stored in your computer. You're supposed to have a backup of that. Okay, the private key of this node is there at your computer. As this current version, they are not yet encrypted. They will in the future. And if the consequence, if somebody gets your private key, is that they are going to be able to run a node with your identity. I don't know if this is going to make if that is a big deal or not, but that's at least you're not going to lose your tokens. And at any time you can come, regenerate all the private keys, submit your profile again. When it gets merged, all other people in the network are going to recognize that these are private keys are news, and that you are going to be, and whoever stole your private keys of these nodes, it will be useful for them. I mean, not useful for them, useless. Okay. Okay. One detail of what I said is that today, when you submit a pull request and it's submitted your profile, any node that is already running, okay, is not going to detect the changes. That is not something that has been coded yet. It's pending for a future version. So until people stop and restart their nodes, they are not going to see the changes on somebody else's profile, because the profile information are loaded and analyzed at the moment the node is started only. Okay, so there is no procedure to detect changes on the fly as of today. Okay, so this is enough information for you to play with this, to test it, to create a node and to make it join the testnet network. That is where people have created a few nodes so far. Okay, so okay, now I will jump into an explanation for developers that would like to see how the code is organized. Okay, I will do my best to explain this because uh, I have already coded this like a few weeks ago, so it's not fresh in my memory. But let's go to the code. The first thing I'm going to do is to stop this node from here so that I can run it directly at Visual Studio. And so what I'm going to do is come here. Here you find network workspace, like Visual Studio Workspace. So you double click here and you have, sorry, let's put this here. Let's put it here. Okay, so now you have the network workspace open. Okay, and in order, the way this is organized, you have to look for the network folder here that has a thing called network app. Okay, and you put it like second, because the first one is the network script. Okay, the network script is the Node.js quote unquote command. When we type node network, what we are running essentially is this. Okay, that in turn is going to call this network root. Okay, that is going to run like a standard procedure for any application we have, that we are loading the dependencies and and the app schemas and the secrets that are needed, and also, and then we run what we call the application. These are like a uh, like a booting process. Okay, this is to enable the command at Node.js. This is uh, like like the booting process, and this is the application per se. Okay, so this is the application. So let me close all this stuff so I can give you a tour of this code. But essentially, if you want to run this, you just position yourself here and you hit F5, and it's going to run, and you can debug anything on this code. Okay, because now it's running inside Visual Studio. Awesome. So once you have this network app, okay, um, once we have the network app, let me see if I can remember what was going on here. Okay, so things are organized in this way. We have two things, or three things. We have the network, or what we call the setup of the network, that essentially are all the objects and components we need to load in memory to have this network node operational, okay, as a network node. We go into details later, but essentially more or less that's the idea. On top of the network or the node code itself, okay, then we are running network services, okay. Today we have two network services, but tomorrow we'll have 3, 4, 5, 10, or as many network services we want to invent, okay. So the first two network services are the social graph for the social application, okay, storing all the relationship between social entities, and trading signals, that is the service that allow the distribution of signals, trading signals, over a peer-to-peer network. These are two services. They are optional to be run, and the way you define it is at the UI, as I explained before. You define which one is going to run, depending on if you put or not those nodes into your own peer-to-peer network node. Okay? So what is going to happen here is that if those nodes exist, then it's going to start the network service, each of the network services. Okay. And the third thing that you have inside the node are the interfaces. Okay. In general, we are using in SuperAlgo the concept of an interface as the gateway through where incoming messages or connections or information is coming into a certain application or module or whatever. Okay, so the context also is needed to well define what we are talking about here. The interfaces of a network node in this case are the network interfaces, okay, meaning the protocol level connectivity. Okay, today we have developed two interfaces because we need them. One is WebSockets, okay, that use WebSockets technology, and the other is HTTP interface, okay. The reason that we need HTTP is because for posting trading signals into the network, we don't need to have an open connection, okay, all the time. We just need to post the signal, and it can be without being connected. Also, because the connection between the nodes, not at this current version, but in the future, will depend on the amount of token power each node has. So the reason for that is because we have to distribute the signals in a certain order depending on the amount of SA tokens each nodes have as token power. And eventually the clients will connect, I mean the applications, the mobile application, the application will connect also depending on the amount of tokens they have. So That is the way we are going to guarantee that the distribution of signal goes in a certain order. And because of that, we need to post the trading signals not at any place of the graph, of the network graph, of how nodes are connected between each other, but we have to do it at the start of the graph, okay, at the nodes that they don't have incoming connections to. So where the node, mean the start of the graph in this case is are the set of nodes that have the highest amount of token power, okay. So every signal goes first to the node that have the highest amount of token power, and from there they start going to the other nodes that they have less and less and less token power, okay. It's not implemented right now, but at least we have the concept, and we already have a HTTP interface that allows entities that don't have that much power to access the nodes that has the top of the token power, okay, because they access via HTTP and not via WebSocket, where it's going to be strictly forbidden to connect if you don't have enough token, a lot of token power to know that have a lot of token power, okay. So for that reason we already implemented both interfaces, but what you need to know now is that we have these two, and one third is coming, that is WebRTC, that is on the way, it's under development. So we will have soon three, okay, and user will define which one to turn on based on the UI, okay. So these are the three main sections here, okay. And let's go now into detail of what's going on here. Okay, so important from here is to highlight is this process, okay. We are calling this process APP bootstrapping process, and you will see it not only at the network node level, but also at the network service level, okay. Imagine the network services are one layer above the the network node, okay, and the network node itself also have probably many layers inside, being the interfaces, communication interfaces is one layer, and on top of that you might have some other, okay. But this is another concept, an app bootstrapping process, okay. What it means is that this is the process needed to be executed uh, at least once, okay, to set up all the information that we need in order for the network service to run. In the case of the bootstrapping process of the social graph network service, of the trading signals network service, is whatever is need to be done to prepare the service to run, okay. So the process includes several stuff. We are going to load this module and see what is going on there. But this is conceptually what is happening here. So let's read what it says here. Let's discover which are the nodes at the beginning of that. Okay, so the first execution here is just a setup of an object that we will need, okay, that is going to store like it's going to store the information of the peer-to-peer node that we are running. For instance, one of the information that it's going to store is everything that you have in this branch from here downward, okay, it is node and all these children, so that we have access to all those configuration easily, okay. So this is preparing that structure, and the app bootstrapping process, what it does, or we will see it on detail, it loads a lot of stuff in memory, but also it also is putting that information inside here, okay. So that's why things are in this order. Then we have a procedure that we run in order to define which are the reachable nodes that we can connect to, okay. Remember that in superalgos we have public and private networks, and private networks have permissions, okay? And that every single node, the node that is running or will be running, belongs to one of all of these networks and might or not might have permission. So here in this procedure, we are going to build a list of all the possible nodes we can connect to depending on all those and all that rationale. Okay, so this is what happens here, and at this module is the one who is going to actually establish the connections, okay, based on the configuration of how many open connections we can have. And we are talking about outgoing connection here, okay? So if we can connect to 10 nodes, this is going to pick from the list that is prepared and maintained here. It's going to pick and try to connect to the maximum amount of nodes, in this case 10, for instance, and it's going to keep those connections open. And by keeping those connections open, that means that when the network service needs to distribute information to other peers, okay, it will use this connection opens to do so. Okay, so this is what is going on here at the bigger scale. What is happening here, well, I already say, is starting the network services that are configured to start, and here starting the network interfaces that are configured to start. Right now they started all, but in the future they will start only the ones that are actually configured at the UI. Okay, so I'm not going to get into detail of this guy because there's not much to say. I'm going to get into detail of this guy because there might be some interesting stuff to check here. Okay, so let's find the guy who is having this. So, okay, it takes a while, but it finally get it. Okay, this is the bootstrapping process. Okay, here is already specified, and you can locate this here. Most of the code is the network project. Okay, the one that is needed both at the nodes and also at the clients. Okay, there this is the most tricky part for you to understand, and is that there are several modules, and I mean a lot of these modules are not going to run only inside the network node. Exactly the same code runs also on the client side. Okay, so the client side, you know which one is running only at the network node and which one is only running, and which one is running both at the node and at the client side because of their location. If they are inside this A kind of folder, okay, that means that they will run both at the network node and at the client side. If they are inside NT, they run only at the network node. So if you see here, you will see that at the network node, we have only the interfaces, okay? Because these are interfaces of the network node. They are not supposed to be interfaces of the client side, okay? So, and also uh, this memory stuff that, okay, cool. So the app bootstrapping process consists of this. It will load all the schemas, plugins, it will load all the user profiles, it will identify all the peer-to-peer nodes, it will identify the node representing the identity that is currently running this app. That means my network node number one is going to identify it and put it in the other place so that it's accessible. Uh, Setting up user social profiles. I'm not sure this is something that is done here because recently, no. Okay, so this is not up to date. I'm going to delete it. 5, 6. Okay, so it's going to set up the storage containers. The storage containers are this thing that we have. This is a project called user storage that allow users to have storage containers at different storage providers, like GitHub, for instance, but we will have more. And um, this also set up this in memory so that it can be accessible later. Okay, so everything this does is about loading information from files, mostly plugin files. Okay, and putting this information into memory maps like user profile by blockchain account, user profile by ID, nodes in plugin files or peer-to-peer network by ID, storage container by ID, permission granted by user profile ID. All this information is pre-digested so that so as to optimize the runtime environment when the node is processing, is executing. So if it is a node running a permission network, for instance, and a connection request is coming and is identifying themselves as a certain profile, then we don't want to go and load the profile plugin and analyze if it has permission or not, load both the ones who is defining the permission and the ones who is we don't want that. We want to have everything in memory so that it runs as fast as it can. So all the permission granted nodes are already in a map. So when we receive the permission request, so we can easily find it in memory without reading absolutely anything, and we can respond as quick as possible. Okay, so this is the thinking behind this architecture. Okay, the bootstrapping process main objective is to pre-digest everything we need in order to process at runtime as fast and efficient as we possible can. Not only to be as fast as possible, because when you're responding at the maximum speed and with the less processing, that means that you can scale much higher because you can receive much more requests in the same amount of time and you're using less CPU. Okay, and so you're making it as scalable as possible. So uh, you will find in an easy to way or easy to read all the procedure that is coming here, loading the user, load the peer-to-peer network plugins, the profiles plugins. Okay, this mainnet, testnet, remember that? Yeah. So the user profile, we load them all and we extract from them information. You will see that this is not that simple. We extract from them some information. Okay, um, you will find some interesting thing, like for example when we get the plugin file content, when we have an object with a plugin, but the format that object is not the one that we needed to have it in memory. So we have this function that converts from a saved plugin into a memory structure where all the node structure will have a parent node or a reference parent, and we can navigate all that structure that is already referenced in a well connected way. Okay, so all this transformation is made once so that we have all this information already available and ready to be used in once we are executing. Okay, so then we have set reference parent for no hierarchy. Well, this is part of the procedures, okay, to establish the reference parent, okay, and the parent nodes and everything, okay. So then we have this extract from user profiles. We need all the load the signing accounts and the storage containers, okay, to arrange them in a clever way in memory map, but ultimately everything is done in order to optimize the execution. Okay, so we do all this digesting here to get the execution as fast as possible. Okay. What is missing here is, as I said before, is the way to detect changes. Okay. So maybe this is going to be run once a minute or once every 5 minutes later in the future, so that whenever there are changes in user profiles and we are updating our installation or plugins or whatever, then we can redigest the information and recreate these maps. And by doing so, we are going to be adapting to the changes. Okay, but that is not implemented yet, it's for future versions. Okay, so this is what you needed to know about the bootstrapping process of the network itself. Okay, um, with that cover, we can probably see very quickly this one, that is the way that we filter out um, the nodes we can connect to. Okay, this is also something that runs both at the network nodes and at the clients. Okay, so depending on the role that we are playing here, because we are running a network node, okay, we are a network peer. Okay, if we are a mobile app or a desktop app, then our role is a network client. So depending on the client, on the role, we are going to filter out the network nodes we can connect to in slightly a different way. For example, if we're a network peer, we are going to avoid connecting to ourselves. Okay, that's an example. Okay, uh, but essentially it's just that. In the end, this ends up with an array here, the peer-to-peer nodes to connect. This node, we are building this array with all the possible nodes that we can connect to. Okay, that's that's in general the idea of this module. Then we have this other one. Remember that the previous one was running both at the client and at the server. That means at network nodes and also at network clients. Okay, so this guy here is going to have an interval. Okay, so pay attention to this. We are going to have an interval running every 10 seconds. These are milliseconds times 10 is 10 seconds. That is going to be uh, retrying to connect to the amount of nodes configured. Okay, so that means this is going to be running once you start it, or once it's started, it's going to be trying to connect again and again and again and again. Okay, until it reaches the 10th connection or 5 connection, whatever you have configured, and from there it's going to stop, or at least not going to be connecting to more nodes. Okay, so that means that if it gets disconnected from one of the nodes for whatever reason, the node is shut down or whatever, then in 10 seconds it should try and reconnect to the same node or to some other node that is available. Okay, and the nodes that is going to consider to connect to are the ones that are calculated in the previous one, in the previous module, um, that I already explained. Okay, so one thing to consider is that this module have a send message feature. Okay, because when we are going to be sending a message, in the cases we need to send a message, we are going to do it through this guy. Okay, and this is useful mostly for client applications. So think of the mobile social trading application or the desktop social trading application. They have this model running with all the connections open, and every time they send a message, it's going to come here and pick a random node from the ones they have they are connected to, and it's going to send the message to any of the 10 nodes randomly. Okay, the reason to do it in this way is because nodes are going to control in the future the rate of queries that you are trying to go through them. Okay, so you cannot ask a node 100 queries per minute probably, but maybe you can ask 10 queries per minute to the 10 different nodes, okay? As long as the node receive your connection and allows you to connect to them because of your social power or your token power, then you will be able to send these queries to them, okay? So we already have implemented a pool of connections so that any of them can be used for the queries or events or whatever you are trying to do with these nodes, okay? So this is all you have to know, and the rest is just read the code and you will figure it out. Okay, so I have already explained all this for guys, okay? Then let's jump into this, into the network services, okay? The network services, let's load one of these guys. The network services, as you can see, if you search for where they are not a part of the network project. They are part of some other project. This network service is part of social trading. The other one is part of trading signals, okay? So this is a layer of code above the network node code, okay? That is happen to be running at the same place, okay? But it's one layer above, okay? So you have to think it in this way. So the social graph network service is what allows the network node to store a social graph. That means all the relationship between social entities, okay? So when you initialize this service and when it runs, it will run all this code, okay? Social trading module storage that is going to load the information that it already have. Social trading modules, the client interface, okay? So again, the concept of interface. The concept of interface is always the gateway through where all the information, incoming information is getting, okay? In this case, getting into this service, okay? So this service has two interfaces. One, what is called the client interface, and the other is the peer interface, okay? So the peer interface is where all the message coming from other network nodes, network services, okay, running inside network node. If a network node is sending me some information, then it's going to run through this module, okay? But if a client application, like the social trading app or social desktop trading app, mobile or desktop, is sending me information, then it's run through this interface, okay? So the concept of interface is the same, but in this case applied to a network service, okay? Then we have this service interface that, to be honest, I forgot about it. Let me see what we have here. Okay, well, I forgot about this. So there is a third interface that is not for other peers or the client application. So when it is another peer, we are talking that a social graph service of network node number two is sending me the social graph network service on network node number one is sending me something. So that goes through the peer interface. In a client interface, it means that the client, the client side social graph network services is sending me a message to the server side social graph network service. Okay. This service interface is when another service that is not the social graph, for example, the trading signal service is sending information or whatever to or a request to the social graph network service, okay, inside the same node. This can happen. We have a use case for that. Okay. So in those situations, we have a service interface. So there are three interfaces inside each node, inside each each service, okay? And this is how they are instantiated and put it to run, okay? And the storage is what allows you to run. So I'm not going to get into details of this because this goes out of context from the explanation of the network itself, but you have a pretty good idea of how this is organized. The trading, if you see here, the trading signals module, the trading signals network service, you will see that has more or less the same idea, okay? In this case, there is no storage because nothing is stored on the with trading signal. New trading signals module client interface, okay? So you have a client interface and a peer interface. So these are for messages coming from the another trading signals network service running at another network node, and this is for the service running on the client side, okay? And yes, there is a client side of each service. So if you see it here, these modules are and these interfaces are defined under the NT folder because they run only at the nodes, okay? But there are modules that run on the client side, that is the counterparty of the server side of the same module, okay? So this is where you will see the network service or the trading signals client, okay? Trading signal client is what you have on the client side, okay? So um, what I'm saying here is that there is a symmetry um, of modules running at different layers and also symmetric between client and server, okay? So if you have the trading signal service running at the network node, then you have a client version of the service. That is the one that is servicing the application, but running inside the same hardware of the application, okay? And that is going to abstract the application from all the network problem because the application will send it to that client side version of the service that is going to be like a proxy to the server side network service, okay? And that is happening at the network service layer, but the same concept is happening also um, the same concept is also happening at the network itself. If you see here, sorry, the network, we said it has the WebSocket interface, right? WebSocket interface. Okay, there is WebSockets network client. Okay, so this is the counterparty of the WebSocket interface. This is the interface is where all incoming messages are coming through. Okay, to the network node, and it's running on the network node. And the other one, the WebSocket network client, is where all these messages from the client side are being sent into the node, okay? So this is the exact counterparty of the other one, okay? There is there is a kind of this is the overall general explanation. There are situations where the node needs to send notification to the clients, okay? And the traffic of information gets inverted, okay? But at least the connection direction is in that way. The client connects to the interface, okay? The client is running at the same hardware the application is running, like the mobile app or desktop app, and this is connecting to the WebSocket interface, okay? And once the connection is open, eventually it will receive notifications of things going on somewhere else, okay? That makes sense for these guys, okay? So that information is coming back, okay, into the WebSocket client, and once it gets back here, that's why you have here an on message, okay, the main workflow here that happens is that uh, if it is a if it is an answer to a request that has been made, then it goes through a certain workflow, okay. And if it is not an answer, then it means it's a notification. We consider it notification, and then it goes to through another workflow, okay, that essentially is going to analyze this network service property here, and it's going to route the message to the client side of the network service that is sending that notification, okay. The network node by itself is not going to send notification because it doesn't have to, it doesn't need to. Okay, but the network service that are running, they might need to send information even without any request. For example, if I like it your post on the social network, then my reaction is going to travel to your phone, okay, even though you did nothing, okay. It's me liking your post, okay. So the way that that happens is that it enters through this function, and because it's not an answer to a request, it's not going through the normal workflow of processing answers, but it's going to go through a workflow where notifications are handled and sent sorry, to the client side module representing the same network service that was sending the notification. So if the social graph network service is sending a notification to this client side network service, it goes through this code, okay. Okay, so that is something important that you have to put in your mental map, okay. So now I'm going to go and explain how the client side is organized in a typical application, okay. So for that, I'm going to, I think I cover all of the important stuff that you need to know at the server side, okay. So on the client side, if you open one of these, for example, desktop, one of these workspaces, okay, the way you organize this usually is like this. You can, I'm going to close some stuff. Okay, so here we have the script that allow us to have a command. Then the booting process where we load the dependencies. Everything is organized in the same way to facilitate the understanding. And we have the concept of the desktop app, okay? So a desktop app is an application that is going to serve applications running uh, on a computer, okay? For example, the social trading application, okay? So this is like in the middle between the the application itself, the specialized application itself, and on the other side, it has two things. It has the peer-to-peer network, and also it has the storage, okay. So it's not that it's going to be just a gateway to the peer-to-peer network, because some things are not going through the network, okay. For example, when you make a post in a mobile or in the social trading application, okay, the content of the post is not sent into the peer-to-peer network. It's used the open storage that store the information at an open accessible point in the internet of your choice. And that means that the desktop app, uh, the application that is connecting to the network app, desktop app. Behind the desktop app is both the peer-to-peer network and also the open storage. Okay, so that's what is behind this. Okay, so the way this is organized is in this way. The desktop app also have its own WebSockets and HTTP interface. Okay, so that's the way that the application UI or the specialized application is going to connect to this guy. Okay, via WebSocket or HTTP. Okay, once they connect and send a message through any of these ways, okay, then it's going to be digested by this machine that behind it is the peer-to-peer network or the open storage project. Okay, so how this is organized? Okay, it's not that difficult. We have, as you can see here, we have setup network or setup interfaces, setup network, and a final setup of the interface. I don't remember why this is divided into, but if it is divided, it's for some reason. Um, Probably because something that is set up here then is needed here. Okay, but we don't want this to run until all this is already set up. Okay, so most likely that's the reason. Okay, so when we are initializing here, we are creating some structure, and some of that structure we will need it here. In fact, we are sending this parameter. Okay, that is the function callback when we receive a notification. Probably even receive is not the best name, but notification would be. Okay, so that's why we initialize this first, then we initialize all the network setup. Okay, and then we run the interfaces. Okay, hold on. um, no. Okay, my explanation was not correct. These are two different stuff. Okay, so delete the previous stuff. What is I was confused. So these are the interfaces: WebSocket interface and HTTP interface, where we are receiving messages from the actual mobile app or the social trading app. Okay, this is correct. Okay, this is one thing. This is not a WebSocket, or this is an web app interface. Okay, so once the message arrive via the network layer, let's say the network, the lower layer transport, okay, protocol layer, okay, once it arrives, then the messages are routed. No matter how they arrive, they are routed to a web app interface. Okay, a web app interface. Once we have it there, another routing will occur. Okay, but this is then is an interface. This is a module that is one layer above of the protocol transport layer. Okay, so we are talking about the application layer. Okay, and this one is the network interface, represents the application layer, but for the things coming from the network, okay, from the peer-to-peer network. Remember that we have the WebSocket client. Okay, that is the protocol level communication layer with the network. Okay, and that we also receive message there, but then the message goes one layer above and get into this guy, that is the peer-to-peer network interface. That is the interface where we receive incoming information from the network, but at the application layer. Okay, not at the protocol layer, but the application layer. Okay, so that's the concept. Make the mental map in your head. Um, and then we have here this module that represents the peer-to-peer network client. Okay, the peer-to-peer network client is this you can imagine this as the counterparty of the peer-to-peer network node. Okay, the network node is all this setup that we made in order for that to operate as a network node. In this case, this is all the setup that we made for this to operate as a network client. Okay, so it will also have a bootstrapping process that is going to reuse most of the module running on the node. Okay, but the purpose of this is for connecting the client to the nodes and not nodes between themselves, because this is going to be running on the client side. Okay, so it's a little bit of a map that you have to make, but everything has a counterparty because it's symmetric. um, and this is how it works. Okay, so I'm not going to go into these modules because they are just a WebSocket server and an HTTP server. Okay, that whatever they get into here, they're going to route it into here. Okay, so let's check this guy first. This guy, okay, when you receive this, what this guy is going to do is to check the network service of the message. Okay, so far all the message are targeting a network service, at least apparently. And so this is routing based on the network service, then it's going to route the message to the network service client depending on the destination network service that we find at the message header. Okay, so it's just routing the stuff. It's nothing more like that, more than that. Okay, so this is it. So this routing inside this guy. Okay, so remember that. Then we have I will come back to this guy later so as not to be so confusing. And we said this, nothing to show there. So let's check this guy. This is the counterparty of the network node, but running on the client side. Okay, so this is the guy. So here you will find that we are doing more or less the same stuff that we were doing at the network node app. Okay, the network node app set it up in a module what is going to contain the identity or of the network node that was running. In this case, is going to contain the identity of the application that is running here. Okay, then it has the same bootstrapping process, exactly the same. So the same code is running on the client side, setting up all these in-memory data maps that allows us to have everything ready. In this case, not for processing the operation, but for whatever we need it for. Okay, so it will also have the reachable nodes. Okay, so it's going to initialize it as a network client. Okay, not as a network peer. And it's also going to have the same module that is going to be trying to connect to network nodes in the same way that other nodes are connecting to each other, but in this case running with the role of a network client. Okay, and it's also going to, it's not also, because this is not done at the network side or the inside the network nodes. This module is about is doing something similar to this one, okay? Establishing connection, but in this case for HTTP connectivity, specifically locating the peer nodes that are at the start of the graph of nodes, okay? Remember, the nodes will form a graph based on the amount of token power they are running with, okay? So this module is going to locate the nodes that are at the top of at the start of the graph, the ones who have more token power, and they're going to test an HTTP connection so as to have it handy. So once we need to send an HTTP post to the start of the graph, then we do it through the send message of this node. Okay, so you're going to send it to any of the nodes that it has there. Okay, so that's what is this about, and it's specifically needed at the trading signals features. Okay, because of what I explained before. So this is what this is about. And then, so this is like the counterparty of the network node app, okay, but on the client. And then we have the client side of the network services, okay. So we are going to run or initialize the social trading and the trading signal network services here so that we are able to run the counterparty or the client side of this network service here, okay. And that is how this is organized, okay. The only thing that I'm going to get into, because all this I already explained it and this is enough explanation what I made, are these guys. For example, the social graph network service client. Okay, let's get into that one. So the social graph network service client, what we have here is when we receive this guy, okay, uh, at the message we will be able to find three type of requests, okay, but this is part of the social graph service. I'm not going to go deep into this because it's not the purpose of the explanation of the overall working of the network, but just to have an idea. Now the message is already inside the social graph network service client because it was targeting this network service. Again, this doesn't mean that it's going to go into the server side, okay? Depends on the service itself, okay? In this case, and in this particular case, this social graph define different categories of requests. It can be a query, an event, or a profile, okay? Query, event, or profile. If you go to the social trading, and you see query types, for instance, you have different query types explained here. List of social persona, unfollow, social persona stat, bot stat, followers, following, post reply, blah, blah, blah. These are queries. Then you have events. Events are these: a new social persona post, a replies to a post, remove user post, follow, unfollow, react with like, with love, with whatever. Okay, all of these are events. And then we have profile types. Okay, profile type is create a user profile, get user profile, create a social entity, delete, save social entity, or whatever. Okay, so in this particular network service, it has its own working. It has a category of different type of requests, and these are treated in different ways. For example, all the ones that are query are sent to the peer-to-peer network. Okay, you will see that depending on the query, they might have some processing here, but in the end, okay, in the end, you will see that we will use this object social graph network service proxy to send the message to the peer-to-peer network, and the result of this, because it's a query, is going to be put in this response as the data property, and is eventually going to be returned back to the caller. Okay, that's how queries work in general. Then you will have, for instance, events. Events also have some processing client side, not that much, but eventually they are sent, okay, also to the peer-to-peer network, and whatever it returns, it comes back to the caller, okay. And then you have another case that is profiles. Okay, profiles are not stored and doesn't go through the network. They are stored using open storage. Your profile picture, your bio, whatever you put there are profiles. Okay, and also the social personas, and that means the accounts that you can use at these social trading apps are stored as part of your own profile. When you use, then you can see them at your profile here at social persona. Okay, social persona one, two, or whatever. Okay, so this doesn't go through the network, but they use the open storage, so they are routed through another workflow where it's going to use the open storage project or saving information at your profile or doing whatever. But this is an example of the client side of the network service uh, being processing certain type of request, not going exactly through the network. Okay, so this is important to know. The other network service client that is trading signals also have its own module and may have or not uh, things like this. Okay, the last thing we need to know is what I left behind, that was this, the peer-to-peer network interface. Okay, in this case it represents the incoming point at the application level of information coming from the peer-to-peer network inwards. Okay, so not coming from the UI but from the peer-to-peer network. Okay, so okay, probably this is outdated because I don't see anything here, and things are being processed in a different way. Maybe um, I'm going to take a note here of this, probably outdated and not going through this way. Hold on, maybe outdated. Okay, I will check that later. Okay, so I think that, yeah, this was rerouted using this stuff. Okay, so no, it's not outdated or not implemented. The thing is not implemented. I mean, we still haven't reached the point of the information coming from the network to be actually sent somewhere. Okay, so that's the point where we arrive. But yes, it's going through this module, and the event receive that we have here is going to be executed with whatever is coming from the network, and that's the point where we are. Okay, so if somebody, if you liked my post, is going to come up to my application here and it's going to just log it here, but it's not going to go to the UI. Okay, because we haven't reached that point. So that's the situation. Okay, so everything is cool. So pretty much this is it. um, so to recap, there's a lot to recap, but I'm not going to make it like repetitive because you can watch the video as many times as you want. But to summarize, um, the development of the peer-to-peer network, the important key points are that it's not just what happens inside a node. Okay, there's a lot of things happening on the client side. There is a symmetry. Okay, and there are layers. We have the protocol layer with different type of protocols being used for communication, HTTP and WebSocket, and WebRTC coming. We have an application layer where you have the code of the node, network node itself, that has a counterparty on the client side, okay? And then you have another layer with the network services, okay? That today we have two network services, but we might have more in the future. And it's also symmetric. You have the network service running at the network node, but also you have a client side of the network services. And we've seen an example that these network services at the client side are not just a router into the network, uh, a proxy to the one in the network, because they might be routing or processing stuff using other stuff that is not the peer-to-peer network. So the client side part of the network service is an important part of the puzzle. Okay, it's not just a proxy. Okay, so you have different, at least three layers, and a symmetry between the network node and the client side. Okay, we have the concept of interfaces that are where incoming information or requests are coming. There are different type of interfaces at the protocol level, at the application level, at the network service level. Okay, and there are the interfaces always are naming uh, who are they expecting to send information. So if I am the desktop app application, my WebSocket interface is the one where incoming information is coming from the user interface, okay, from the user specialized user applications. And my network interface is the interface where information coming, and that is at the protocol level. Then at the application level, we have the web app interface that we consider the web app, the user interface. Okay, so once it gets into the protocol layer, then it goes up to the user, to the application layer, and from there it goes up to the network layer, okay, to the network service layer. Okay, that doesn't, not to be confused with the network itself. So once it is at the network service layer, then it can be processed there or routed to somewhere else, or even into the peer-to-peer network to reach the network service running at the node. Okay, so all this is all the structure. Then you also have the interface at the client side, the application interface of the network. So everything coming through the network goes through that interface. First coming through the protocol layer interface, that in this case is WebSocket only for now, but WebRTC also, and then is going up into the application layer interface of the peer-to-peer network, and from there routed to the network layer, one layer above, okay, of the client side of the network service that is sending that information into the client. Okay, so these are all the circuits that you can have in your mind. Once you understand this, you will be able to add more network services or add more pieces into the puzzle, because now it's just adding more pieces. Somebody's adding WebRTC, that is specifically something at the protocol layer. So we add one more technology for communication at the protocol layer. Somebody's thinking of adding another network service. Okay, now you know that you have to add the the side of the network node and the side of the client side. Okay, and whatever you're doing, it might have uh, things at both sides, or for sure they will have their modules. Okay, so this is all you need to know of version 2 of the peer-to-peer network and the current state of things. Thank you for watching, and see you next time.